Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to basic mathematics on linear equations in two variables. So far we have covered various methods for solving a system of linear equations in two variables with substitution method, then elimination method, and then cross multiplication method. So in this video we are going to discuss the concept of the conditions. Sorry, this is very thick. Yes, okay. Now the various conditions for solvability of a pair of linear equations in two variables. Okay, so we have touched these this concept in the very first video when we started substitution method, but still we will elaborate on it. So let us say we have a system, a pair of linear equations in two variables which are given by a1x plus b1y plus c1 is equal to 0. This is the standard format where a1, b1 and c1 are the real numbers. a1 is the coefficient of x, b1 is the coefficient of y, c1 is the the real number, which is the constant, which has no other variable because there are two variables only. This is the first equation, and the second equation is a2x plus b2y plus c2 is equal to 0. Now, so far the methods that we have used to solve it is for a unique solution, a single solution. So how we determine how many number of solutions, the values of pair of values of x and y. Number of solution means, a solution means here a x and y value pair. Okay, this is a particular solution. So how many number of solution they exist for a particular system of linear equations in two variables, that we can determine from these values a1, b1, c1, a2, b2, c2. How? So there are some rules, some conditions. Now the first condition, suppose a1 by a2, that is the coefficient of x for the first equation and the coefficient of x for the second equation, the ratio of those two is not equal to b1 by b2, that is the coefficient of y for the first equation, coefficient of y for the second equation. If the ratio of a1 by a2 is not equal to the ratio of b1 by b2, then in such case the system of equations, they have a single or unique solution, which is one particular combination of x and y which satisfies these two system of equations. Only one pair, one value of x, one value of y. It is called as a single or unique solution. Okay, now if we have a1 by a2 is equal to b1 by b2 is equal to c1 by c2. a1 by a2 coefficients of x, b1 by b2 ratio of coefficients of y, and c1 by c2 the two constants which are all real numbers. If these three ratios, they're equal, then the above system of linear equations, they have infinite number of solutions, many solutions, infinite number of solutions. Okay, So a lot of combinations, that is x1, y1. I'm just saying this. So this is one solution, x2, y2, then x3, y3, then this goes on and on up to xn, yn. So a lot of combinations, lot of pairs of x and y values which satisfy the above system of linear equations. So a lot means infinite. So it goes on and on and on, the combinations, the pair of values. Then the third case. Now, okay, let's go to the third case, then we'll discuss that part. Okay, the third case. So in the third case, we have A1 by A2 is equal to B1 by B2. Okay, A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2. So in this case, where the ratio of the coefficients of x and y, they are equal, but they are not equal to the ratio of the constants for the two equations. In that case, the above system of equations, they have no solution. They have no single value, pair of value of x and y which satisfy the above equation. Okay, they have no solution. Now, the first two conditions in which there is at least one solution which exists, a single solution, that is unique solution, or infinite number of solutions. Those two conditions, in those two conditions, the system of equations, they are said to be consistent. Okay, they are said to be consistent. Okay, if it has at least one solution. Now this condition, in this condition, the system of equation is said to be inconsistent because it has no solution. Okay, so these are the three conditions. Now we'll be solving some questions regarding conditions for solvability of a linear equation in two variables. Now another thing, there is also a graphical approach. Okay, a graphical approach. Now we know that the equation of a straight line which requires two variables, it is given by y equals to mx plus c, this way. So basically it is a linear equation in two variables. So I will discuss in graphical approach in detailed manner, but here you just understand. So when each of these equations, they represent a straight line. Okay, line 1 and line 2. So for if I have to show this, the above three situations in a graphical manner, it will be something like this. So the first case in which there is only a single solution. So let's say this line 1, it represents equation 1, a1x plus b1y plus c1 equals to 0. So if there is only a single solution, okay, a single solution, in that case there will be only one intersection point of the two lines which represents the two equations. This is line 1, this is line 2, and this intersection point, it represents the single solution. Now the second case, this is first case. The second case in which there are infinitely many solutions, it is a pair of coincident lines, lines which overlap over each other. So like this, and again another line which is, I'm not able to draw it perfectly, but it is two overlapping lines, coincident lines. So all the solutions, they are, there are infinite number of solutions, there are infinite intersecting points, overlapping points. Okay, so what does an intersection point mean? It means it represents a point where both the equations, they are satisfied by the same value of x and y. So in unique solution case, there is only one intersection point. In infinitely many number of solutions, the second case, there are infinite number of common points. Intersection point is a common point. So here there are a lot of common points because it's a pair of coincident lines. Now when there is no solution, so these intersection points here, lot of intersection point, it goes on and on and on in this direction and in this direction. So it is x1, y1, x2, y2, x3, y3, like this. It goes up to this here, x and y, lot of common points. This is the second case. Now in the third case, when there is no solution, it is shown, the graphical condition is a pair of parallel lines. Parallel lines never intersect each other. So no intersection point, no common point means no single solution which satisfies both the equation. So for the first condition is a single intersection point. Here a pair of coincident lines with infinite number of common points, common overlapping points. Here this is here the third case, no solution, it is a pair of parallel lines with no intersection, no single intersection point, no common point, it means no solution. So this is the graphical depiction of the above three conditions. Okay, so we'll discuss it in detail in the graphical approach. For now, I just wanted to give you a basic idea of what it is. Okay, so this is the thing.